Welcome to The Explainer. Okay, if you've got a software engineering exam on the horizon, this is definitely for you. We're going to build the ultimate study guide for one of the most important and, let's be honest, often confusing topics out there, requirements engineering. We're going to break down everything you need to know so you don't just pass your exam, but you actually get why this is the core of building great software. So let's dive right in with a question that really gets to the heart of this whole thing. What do you think is the single most expensive mistake you can possibly make when you're developing software? Is it some kind of crazy bug in the code, a huge design flaw? Just take a second and think about it. The answer? It's a requirements error that you find way too late in the game. Just look at this graph. Fixing a problem when you're still in the requirements phase, that tiny little bar on the left, it's cheap, it's easy. But fixing that exact same problem once the software is already out there, in the maintenance phase, whoa. Look at that massive bar on the right. The cost just explodes. So getting requirements right from the start isn't just a nice idea, it's just plain smart. Okay, so here's our game plan for today. We'll start by digging into that cost of getting things wrong. Then we'll nail down what a requirement actually is. We'll walk through the four-step process, get really clear on functional versus non-functional types, look at how to capture the vision, and finally, we'll talk about why you have to embrace change. All right, let's jump right into our first big topic, defining the blueprint. To avoid those super costly errors we just saw, you have to have a solid foundation. And that foundation, well, it all starts with a crystal clear answer to a simple question. What exactly is a requirement? So this is probably the most important distinction you need to lock in your brain. A requirement is all about the what, not the how. It's about what the system needs to do from the outside, from a user's point of view. For instance, the system must let a user log in. That's a what. It says absolutely nothing about what programming language to use or what kind of database is in the background. That's all the how, and that stuff comes way later. And this right here is what separates a vague wish from a solid engineer-grade requirement. Saying a screen should appear quickly, what does that even mean? How do you test for quickly? You can't. But saying it must appear within 2 seconds? Now that's a verifiable, testable fact. A good requirement can always be measured. Nailing this shift from just a desire to actual hard data is a huge engineering skill. So think of these as your quality checklist, right? For every single requirement you write, you've got to ask yourself, is it unambiguous? Can it only be interpreted in one way? Is it verifiable, like our 2 seconds example? And hey, is it even feasible to build with the time and money we have? Every single property on this list is a safeguard against those misunderstandings that lead to those crazy expensive fixes later on. So now that we know what a good requirement looks like, how do we actually create them? Well, it's not about just writing a random list. It's a structured 4-step engineering process, and you'll find yourself repeating it in a cycle as you learn more and more about the project. So it all kicks off with elicitation, which is really just a fancy word for gathering up all the needs from everyone involved. Then you move into analysis, where you try to make sense of it all and sort out any conflicts. Next, you specify them. You write them down on a formal document. And finally, and this part is so important, you validate them. You go back to the stakeholders and make sure, hey, did we get this right? And remember, this isn't a one-and-done deal. It's a loop you'll keep going through as the project grows. Okay, seriously, if you're taking notes, put a big star next to this one. Understanding the difference between functional and non-functional requirements is one of the absolute bedrock concepts in this field, and I can almost guarantee you it's going to pop up on your exam. Here's a super simple way to keep them straight. Functional requirements describe the features, the what the system does. Think of them like the bullet points you'd see on the back of a products box. Non-functional requirements, on the other hand, describe the qualities and constraints, the how well it does it. We're talking about things like performance, security, and how easy it is to use. A system can be perfectly functional, do all the whats, but still be totally useless if it's slow as molasses or easy to hack. You absolutely need both. Okay, so we've got our requirements. We know if they're functional or non-functional. Now what? The next big step is capturing that vision. How do we document all this stuff so that everyone, from the client who has the idea to the developer writing the code, is on the exact same page? This is where we create that formal blueprint. And that blueprint, it's called the Software Requirements Specification, or SRS for short. You need to think of this document as the single source of truth for the entire project. It's the official contract. It details every single functional and non-functional requirement. So when arguments happen later on, and trust me, they will, the SRS is the rulebook everyone turns to for the final answer. But let's be real, a huge text document can be pretty dry, right? It can be hard to really picture how things work. That's why we use models to bring it to life. And a really powerful tool for this is the use case. We often draw them using something called UML, the Unified Modeling Language. Use cases are great because they let us visualize the system from the user's point of view, showing how an actor, like a customer, interacts with the system to get something done. And this four-step process, it's such a great way to think through how a user is actually going to interact with your system. You start with the ideal happy path, what happens when everything goes perfectly. But then, and this is the crucial part, you have to define the alternate flows and the exceptions. What if the user types in the wrong password? What if the internet connection drops? Thinking through all those messy scenarios is what separates good software from robust, real-world software. Okay, time for a little dose of reality. You could write the most perfect, detailed, validated set of requirements the world has ever seen, and I can absolutely guarantee you, they are going to change. Now, this isn't a sign that you failed. It's just a natural, totally expected part of developing software. It's just the nature of the beast. As the team learns more, as the customer actually sees the product start to form, and as technology changes, everyone's understanding of what needs to be built is going to evolve. So the key isn't to prevent change, it's to have a solid process to manage it. And that, my friends, is where the discipline of requirements management comes into play. It's the formal process for controlling all that change. It's about tracking every requirement, analyzing what happens if we make a change, getting the right approvals, and making sure the whole team knows what's going on. It's the thing that stops a project from just falling into total chaos. So we'll leave you with this question to chew on for your exam prep. Mastering requirements engineering isn't really about creating some perfect, unchanging document at the start. It's about building the processes and the skills to adapt, to communicate, and to build something amazing on a foundation that's always shifting. And that is the true mark of a great engineer. Good luck.